unit is on functions. So a lot of this is review from when we've had functions, but there's a lot of different terminology in this one. So it's going to be important to pay attention to that specifically. So to begin with, what is a function? A function is it corresponds to different variables. So it corresponds each element, let's say x, from set A, to exactly one element in set B, which would be y. So if we look at something like this, this is the time of day, like maybe we'll say this is the 1 o'clock, 2 o'clock, 3 o'clock, and then this is the Celsius temperature. You can see at 1 o'clock it was 9 degrees, 2, 13, 3, 15. You can see that 4 o'clock was also 15. That's okay because it says it's exactly to one of them. It can be the same as a different one from this one, set B. What we could not have if this were a function, let me get the color to show this, is you cannot have one of the sets from A, the x value. It can't be like this. You couldn't have 5, B, 12, and 10. One, that doesn't make any sense for this situation because it can't be two different temperatures at 5 o'clock. But in general, it will not be classified as a function if this set A has two answers from set B. So you notice I've labeled these on the top, the domain and the range. The domain is going to be the inputs, what's going into the function, and the range is going to be what comes out, that's set B of the function. So if we look over here at testing functions, so we want to test to see if this is a function, then that means that we would solve for y. That's going to be how you test a function. And depending on how many solutions you have, says whether or not that will be a function. So if we look at this one, we will move x to the other side, x squared to the other side. We have y equals 1 minus x squared. Okay, so we have y equals 1 minus x squared. That's only one solution, so this one would be a function. Okay, if we go down to this one. So let's add x to the other side, make it positive. Y squared equals x plus 1. Do the square root. Y would equal plus or minus the square root of 1. This would not be a function because it's either going to be plus or minus. That's two answers. That's okay as far as it being an equation, but it won't be classified as a function. So that's going to be the difference between those two. So if you want to test a function to see if it's a function, test an equation to see if it's a function, solve for y. And if you have one answer, then that's going to be a function. And if it has something like two answers like this one, it will not be a function. Something also, terminology, is going to be an independent and dependent variable. You should be have had this in science class, but in math, for functions, what we're looking at is the x is the independent variable, that's the one that we put in, and y is the dependent variable. So whatever y is dependent on what we put in for x. So again, that's just a terminology kind of thing. The function notation, again, I listed this with the domain. So if we're putting this together now, we have the x's, the domains, and the inputs. So this function notation, the input is x, the output, f of x, which again we can see it's substituted in place of what y would be. And this is, f is actually the function name, and this f of x is actually going to be the value. And then you have an equation, f of x equals 1 minus x squared. So we just use the same thing as over there. So if you want to plug a value in, and again, this should be the view from what we've done in functions, say they give you this, g of x equals negative x squared plus 4x plus 1, and they want you to solve for g of 2 and g of x plus 2. So we just plug in a 2 wherever we see this. So we have negative 2 squared plus 4 times 2 plus 1. So we have negative 4 plus 8 plus 1. This still equals that. which is going to equal, we have negative 4 and an 8. It's going to be positive 4 plus 1, which is 5. Okay, just a simple substitution, and then notice that I put my negative on the outside there, so pay attention to that. If we have an x plus 2, this one we have negative, again it's on the outside, x plus 2 squared plus 4 times x plus 2 plus 1. Okay, you can't just leave it like this though, we've got to simplify it. So if we do this, I'm in a little diagonal here, I'm going to multiply this one out, so we have x squared plus 4x plus 4 plus 4x plus 8 plus 1. So if we multiply out this negative throughout this, it's going to change my signs on everything inside. Plus 8 plus 1. Okay, so then I have my negative x squared. We have a negative 4x and a positive 4x. And then we have negative 4 and 8. It's going to give us a positive 4 plus 1 is 5. So that's going to be my answer. Again, you always want to simplify and cancel, and something like this as much as possible, because it'll want the answer to be simplified, even though it doesn't specifically say that. Okay, the next thing that we're looking at is going to be called piecewise defined function. Piecewise is kind of a funny name. It just has different pieces, and it actually makes sense with what we're talking about when you look at it. But the definition is that it's a function defined by 2 or more equations over a specified domain. So it's going to look something like this. It says f of x equals x squared, so this is going to say it's including both of these, x squared plus 1 when x is less than 0, and x minus 1 when x is greater than or equal to 0. So you can see there's 2 equations for the function, and then, excuse me, we have a specified domain. X, remember x is always going to be a domain, x is less than 0, and this one, x is greater than or equal to 0. So they had to specify, and that's what's going to make it a piecewise defined function, because the pieces are defined by the different domains. So if you get instructions to evaluate it when x equals negative 1, 0, and 1, we have to look at the equations individually. This negative 1, I look at it, okay, well, negative 1. X is less than 0, x is greater than or equal to 0, so it's going to be this one, my top equation. So I substitute it in. Negative 1 squared, so we get f of negative 1 equals negative 1 squared plus 1. So this is the same thing as 1 plus 1, which is 2. Okay? 0. Okay, so which equation will that one be? Well, this one's equal to, so it's got to be my bottom equation. F of 0 equals 0 minus 1. Okay, so that's going to equal negative 1. And then this one, 1. Again, we're still looking at my bottom equation because it's greater than or equal to 0. So we have 1 minus 1, which is 0. So it's essentially the same thing as what we were doing in this question, but you just have to look to see which equation do I use, and that'll just depend on what they give you and what the specified domain of the equation is. Okay, so another thing to think through is going to be implied domain. There's explicit domains and there's implied domains. In this example, this is an explicit domain because it tells you explicitly this is what the domain is. Sometimes it's called an implied domain. That means it's not going to be told to you, it's just implied by the equation. So this definition looks really long, it's just I gave examples with it. The set of all real numbers, the set of all real numbers for which the expression is defined. So all of the values that could be solutions, all real numbers for which it could be defined. So if we look at this, f of x equals 1 over x squared minus 4. Now we know x in this function cannot be plus 2 or minus 2 because that would make my denominator 0. We can't divide by 0. So that an implied domain to this one, unless it's given otherwise, is going to be all real numbers except plus or minus 2. That's an example of an implied domain. You'd also have an implied domain with something like this. F of x equals the square root of x. Well, we can't take a square root of a negative value, as you can see by when you type it in a calculator getting an error message. So the implied domain is x is greater than or equal to 0. Well, if we look at the notation we've been using in the beginning of this prerequisite chapter, it can include 0. So we have our square bracket there, 0, comma, all the way to infinity. So it can include everything greater than 0. So if we look at this and they ask you to find the domain of these different situations, this one's nice and easy because we know that the domains are x values, like set A, x's. So in this case, if they say find the domain, well, the domain's going to be -3, -1, and 0. It's going to be whatever my x value is. So those are the nice ones. They're very straightforward. You can see them right there. Okay, now if we look at this one looks similar to one of the examples with the definition. In this one, we know we can't have -5 in my denominator because that would make my denominator equal to 0. So this would be all real numbers except -5. Okay, just to make sure you can say x does not equal -5. I don't know if you can see that -5. Okay, so it's everything, it's implied it can't be a -5 because it would make your denominator 0. Okay, what about this one? Finding the volume of a sphere. Okay, and then they give you the volume of a sphere in the equation. Now, if we know the volume of something, we know that it has to be a positive value. You can't have a negative volume of something. So what we want to do is we know that my radius then, my unknown that I'm plugging in, has to be greater than or equal to 0. It could be anything else, but it has to be greater than or equal to 0. And you say, how could it be 0? Well, if you didn't have a sphere, then the volume of it would be 0. So that would be that one. So you just have to look at it. If they didn't tell you it was the volume of a sphere, if they just gave you this equation, then this would not be an implied domain. It's only because we know what it is we're trying to find. So it does also depend on the context of the equation. What is the equation trying to find? So pay attention to what that is because it will depend if it's implied or not. And then if we have something like this, well again, it's a similar situation as the other square root, so we know x cannot be plus or minus 2. It can be all other real numbers, but we have to have a 0 or above in my square root to be able to solve that problem. Okay, so that's going to be my implied domain. The last section of this unit was the application of all of this. So we have 2 application questions here. The book has even more application questions to look at. It says to express the volume as a function of the radius. So here we go. So if we wanted to do this, first of all, our equation for the volume is going to be pi r squared h. You guys all knew that, right? Though, because we know the volume of our cylinder here, it's going to be like the circle on the top times the height. Okay, so we want to express the volume as a function of the radius. Okay, so that means we do not want h, we only want the radius squared in my equation. So if we did that, we'd say the volume equals pi r squared, and instead of h, we're going to put times 4r. So we multiplied it by that. We simplified it, it would be pi r, would be 4 pi r cubed. Would be the same thing if we multiplied it out. Again, expressed as a function of the radius means that we only have the radius listed in there. If they're asking you to express the volume as a function of the height, that means we're going to have the height in there and we're not going to have the radius. Now, if we look at this and we want it to be what's the radius also equal to for the height, well, to get the radius by itself, we divide by 4. So the radius is also, the height divided by 4. Okay, so instead of writing it in this way, we're going to say the volume equals pi times, instead of the radius squared, we're going to say the height over 4 squared, again, they're the same thing, times h. So if you can see, again, if it says as a function of the height, we want the heights in here, okay? So if we multiply this out, we have the volume equals pi times, it's the same thing as h squared over 4 times h. If we multiply this all out, we would have pi h cubed over 4. Okay. So, as you see, it's a similar idea, but the question is, what's the focus? Are you focusing on the height, h, or are you focusing on the radius, r? Express it whichever one they're asking for specifically. Then this last example, this is an example of what you would see somewhat in calculus. For f of x equals x squared minus 4x plus 7, they want you to find f of x plus h minus f of x. That looks really complicated, but let's see what we can do with this one. So f of x plus h. So instead of my x's, I'm going to plug in x plus h. It's not as complicated as what you might think. So we have, and in this one, let me just make sure that, okay, I've done the thing correctly before we do it. Okay, so we have x plus h, that's this one, squared, minus 4 times, instead of x, it's x plus h, plus 7, that's this one, f of x plus h right here. Now we want to do minus f of x. Well, that's the same thing as we had, but again, remember to put it in parentheses because we have minus all of this, so we have x squared minus 4x plus 7. Okay, so we want to, I know this is going to look a little bit nasty, but we got to multiply this out. X squared plus 2h plus, 2xh. I'll make some space here. 2xh plus h squared minus 4x minus 4h plus 7. And then this minus is going to change all my signs. Minus x squared plus 4x minus 7. Okay, now we got to simplify. See an x squared and a minus x squared in this one. See 2xh doesn't have anything, we don't have another x squared. Okay, I see a minus 4x and a positive 4x, plus 7 and a minus 7. I think that's it. So we have h squared plus 2xh minus 4h. I see we have h's in common here, so I'm going to take an h out. H times h plus 2x minus 4. And I think actually we were going to, oh, I'm sorry. What am I doing here? Oh, I was right. I didn't think this looked right. Oh, we want to find this all over h. Okay. So, this is all over h root. That doesn't really affect anything until now. H. This is all over h. Just give us some space here. This one's over h. So that means when I take out my h, we're going to have h plus 2x minus 4 over h. And you can see these can cancel now. And so my answer is going to be h plus 2x minus 4. So that's going to be my whole answer. Again, something a little bit more complicated like this, you just have to pay attention. Again, it helps to have the question written correctly. Excuse me. So just be careful when you plug things in, especially with negatives, that you're multiplying it out correctly or that you're combining them correctly. So what's most important is to know if it's a function. So in this case, again, this is not going to be a function because it has two values that it's equal to. So just be careful when you plug it in. Make sure that you acknowledge the implied volume, so the implied domain, so that you know what is going to be a possibility for these. And when you're plugging things in, just make sure you know what the focus is. So again, let's go ahead and stick with the multiples of 5, so you have some of the answers on this. Okay,